Good evening, guys. Welcome to Sapience Education. For more details, you can visit our websites. So today I'm going to discuss about the following topics, that is Zeroth Law of Thermodynamics, heat, internal energy, work, and first law of thermodynamics. So let us discuss about one by one. So what is Zeroth Law of Thermodynamics? So as per statement, if a system A and B are separately in a thermal equilibrium with the third system C, then A and B are in a thermal equilibrium with each other. So let us see here. A is from diagram A is thermal equilibrium with the C. B is also thermal equilibrium with C. So it means that A and B both are in a thermal equilibrium. So from one thing you can also understand from this figure also, let us consider. This is A, this is B, and this is a C. There is a adiabatic wall. It means that no heat transfer take place. No heat transfer takes place. So if no heat transfer take place, then there is a no exchange of heat energy. So in this situation, what will happen? There is an exchange of heat energy from A to C separately. So it is not like that it is A, C and B is connected. No, just see the image. C is the same system. First of all, I have done equilibrium with A, equilibrium with B separately. So if system A is in thermal equilibrium with C and B is also in a thermal equilibrium with C, then there is no connection between A and B also. Then also A and B both are in thermal equilibrium. Both are in thermal equilibrium. And this is what Zeroth Law of Thermodynamics states. Thermal equilibrium means what? Let us see here. There is a body P, and there is a body Q, and it has been connected, and it has a temperature, let us say 100 degrees Celsius, and it has a temperature of 80 degrees Celsius, and both will be connected. Then what will happen? There is a instant heat transfer or energy transfer take place from P and Q. After a certain time period, what will happen? After a certain period of a time, P may attain the temperature of 90 degrees Celsius and Q also may attain the temperature of 90 degrees Celsius. So when these both have a same temperature, then what will happen? No exchange of heat will happen. So it means that this body is in thermal equilibrium. Body is in thermal equilibrium. So this is what all about thermal equilibrium is. Now from figure we can also understand from this figure also. This is a system A, this is a system A, and this is a system B. Both are separate, no connection. Adiabatic wall means what? No exchange of heat. No exchange of heat will happen. If there is a no exchange of heat will happen, then there is a no exchange in a heat energy will happen. Now see here, dithermal wall is there. That is, system A and C both are connected in such a way that there is an exchange of heat will happen. There is an exchange of heat will or any form of energy will happen. So when there is a system A and C both are connected, so what will happen? System A and system B try to acquire a same temperature, that is temperature of A is equal to temperature of C, because both will attain a thermal equilibrium. Again, system B and C are connected in such a way that there is an exchange of a heat energy or exchange of any type of energy. Then what will happen? They acquire a thermal equilibrium position. Thermal equilibrium. So what actually happened? Thermal equilibrium is what? Temperature of this system and temperature of a system B as well as temperature of a system C both are equal. Both are equal. Since here we have got temperature of A is equal to temperature of C and temperature of B is also equal to temperature of C, then definitely temperature of A is equal to temperature of B, right? And this is what Zeroth law of thermodynamics states. Zeroth law of thermodynamics introduced the concept of a temperature also. Concept of a temperature, because whenever they have a same thermal state or same temperature, same degree of hotness or coldness, then there is a no exchange of heat if they have a both thermal equilibrium. So two systems are said to be in a thermal equilibrium if its temperature are same. Now temperature is what? It is the measure microscopic physical quantity which measures degree of hotness or coldness. Let us consider there is an object, it has having so many molecules, so it has some of the energy, so molecules are traveling up and down, up and down, up and down, due to which it has some of the energy, and this energy has been identified by the temperature degree of the hotness or coldness. Let us take another solid particles, and it has also a molecular movement, but the speed of the molecular speed is very high, very high. So if it has very high, it means that its degree of hotness is very high, because due to molecular movements temperature increases. It means the temperature is high and this temperature is low due to molecular movement only. So the temperature is a parameter which shows you how much it has been moving, how much energy it contains, how much molecular movement is happening in a microscope. So that is why temperature is a macroscopic physical quantity which measures the degree of hotness or coldness. Degree of hotness and coldness. There is no pure hot or a cold body. We can't say that pure hot and cold body is there. So it is a comparable phenomena. Even 200 degree is also cold as compared to 400 degrees Celsius, and even minus 20 is also hot as compared to minus 40 degrees Celsius. So the temperature will always come from 400 degrees Celsius to 200 degrees Celsius. Temperature will always go from heat will always flow from 20 degrees Celsius to 40 degrees Celsius, minus 40 degrees Celsius. And heat will always flow from high temperature to a low temperature. So let us consider T high temperature is 400 degrees Celsius and lower temperature is 200 degrees Celsius. Then heat will always flow from T high temperature to low temperature automatically. Now what is heat? It is an energy in a transition between the system and the surrounding. Let us consider this is a system and outside it is a surrounding. It has a temperature of 200 degrees Celsius and surrounding temperature is 30 degrees Celsius. So what actually happens here? So heat will try to flow from this body to this body. So heat is energy or transition. Transition means what? Due to temperature in difference, there is a transition from high temperature to lower temperature. It is the form of transition phenomena. Flow energy. It is a flow energy at all. We can't say that an object contains the heat. It contains a heat. It is wrong to say. It contains heat. It is wrong to say. It contains internal energy. It contains its energy, but it is wrong to say that it contains heat. Heat is a flow phenomena. So heat flows from high temperature to lower temperature, but any body does not contain heat. Heat only flows when there is a temperature difference, that is high temperature to low temperature. So I hope you have understood now the concept of a heat. It is a fully flow phenomena. A given gas has a certain amount of internal energy is a meaningful statement, but we can't say that it has a sum of the heat energy or a work energy. No, it is never to say that. We can say certain amount of heat has been supplied from one body to another. So supply phenomena, flow phenomena, heat as well as work is a transient phenomena. It is transition. So heat transit due to temperature difference delta T, and work transition happens due to pressure difference. No matter how much initial pressure is, no matter how much final pressure is, no matter how much initial temperature is, and no matter how much final pressure is, only there is a difference, then only there will be an exchange of heat happens. If a body has 1000 degrees Celsius and the surrounding has also 1000 degrees Celsius, so no heat exchange will happen. But if a body has a minus 40 degrees Celsius and another body has a minus 60 degrees Celsius, so there is a 20-degree difference. And due to this phenomena, heat exchange will happen from high temperature to low temperature. So this is all about heat. Now next topic is the internal energy. The name is specified that it is all about internal part. So let us consider there is a gas inside any type of cylinder. There is a gas like this. Gas has a sum of the movement, that is, it contains the velocity. If any gas molecules contains velocity, it means that it has kinetic energy. Gas X molecules is changing its position, so it means that it has some configuration change or position change. And if it has position changed, then what will happen? We can say that it contains a potential energy. So the combined form of kinetic energy as well as potential energy of a gas molecules inside any container is known as its internal energy. So the internal energy of a system is the energy passes by the system due to its molecular motion and a configuration. Okay. Energy due to molecular motion UK can be represented as kinetic energy. UP can be considered as a potential energy. So when we combine total internal energy, so it will be UK plus UP. I hope you have understood this. Now change in an internal energy of a system is independent of the path. It does not depend upon the path. What type of process is being there. It only knows about the initial as well as final point. So let us consider there it is a gas container. So initially what happened? Initially it has internal energy UI. After applying heat, what will happen? Its internal energy became U final. So the change in internal energy can be considered as U final minus U in internal. There may be a heat source, there may be a pressure source, there may be a work done, no matter which type of things has been applied. So change in internal energy only depends upon final as well as initial internal energy, and this is what it is known as independent of the path. So I will more elaborate this independent of the path function as well as point function in a further video. So let's hope that you have understood this one. Okay. And after that, I will explain you in a broad way with the graphical method. Now let us discuss about the basic definition of work. It is the transfer brought about the other means, such as moving the piston of the cylinder containing a gas by raising or lower the gas connected to it. Let us consider there is a piston and there is a cylinder. Sorry, there is a cylinder and there is a piston. So this part is known as piston. So what will actually happen here? So there is a gas molecules inside it. Somehow if we apply a heat or anything, we don't know, due to which what will happen? Due to which there will be a movement of the piston in upward direction. So if there is a movement in a piston of the upward direction, so what will happen? Work will be done. Why? Because work has a formula is equal to force into displacement dx. So let us consider this piston has been moved for a distance dx, and the pressure in the gas inside is your P, and the area of this piston will be A, So what will happen, force can be considered as pressure into area, because pressure has a formula, pressure is equal to force by area. So force can be considered as a pressure into area. So we have multiplied is pressure into area into dx. So as dx into area, so what will happen if it will move upward, so there will be a change in a volume. So area into dx can be written as a change in a volume, so p dv. So this is all about work done. Okay, so here whenever there is a movement, physical movement will happen, then there will be a change in a value volume, and due to this there is a work is to be done by the gas. So here work has been done by the gas in displacing the piston by the distance of dx. So I hope you have understood this phenomena. Now let us consider first law of thermodynamics. Before that, we can understood some of the things. Let us consider piston cylinder here. So this is a piston cylinder system. So this is a cylinder, this is a piston. So this is a piston, and the gas inside it is there. There is a gas inside it. It has a it has internal energy ui as initial internal energy, and we have supplied a heat. So when we supply a heat, let us consider delta q has been supplied heat. So due to heat energy, what will happen, molecular vibration will increase, and due to which it will apply a pressure on this piston. So after a certain time, what will happen, this piston will reach to this top level. So when this piston has been reached to top level, so it means that work has been done, that is del w, small work done has been there. So what actually happened, there is a work done happen. Work done has been done due to the movement of the piston. So apart from this, there may happen that its internal energy changes to UF state, that is final internal energy. So change in internal energy can be considered as U final minus U initial. So what actually happens, we are supplying a heat. So heat has been converted into the internal change in internal energy, that is del U plus delta Q. Delta W is the work has been done. So finally we can conclude that work done by the gas plus change in internal energy is equal to heat supplied. Whatever we are supplying a heat to this piston, this has been converted into change in internal energy, and there is a work has been done by this piston cylinder. And this is what first law of thermodynamics states that. So as we have discussed, according to it, heat given to the system del q is equal to the sum of increase in its internal energy, that is del u, work done by the system del w against the surrounding. So finally the first law of thermodynamics is del q is equal to del u plus del w. It is applicable for all process. It is applicable for all process. Now internal energy of a system can be changed by supplying heat. So here we have already discussed, if you apply a heat, so what will happen, change in internal energy will happen. There is also called work input or output. So see here, if you have stopped supply of heat, let us you have not given a heat, if you are increasing work or doing work on the piston by changing its volume or just taking out, so what will happen, there will be also a change in an internal energy. So it means that if there is a work input or output from on the system, so there will be a change in an internal energy of the system. So let del q is the heat supplied from the surrounding, del w is the work done by the system or to the surrounding, and del u is the change in the internal energy of the system. So whatever system is there, so we have supplied del q heat, work has been done by the system as del w, and the internal energy increase has been done as del u is the increment in the internal energy. So finally delta Q is equal to delta W plus delta U. So here delta Q minus delta W is equal to change in internal energy. So what actually happens? So we have delta Q, that is change in heat or exchange in a heat or supply of heat is suppose 2000 minus work done by the system is 1000. So finally we are getting internal energy change in 1000. It does not depend upon the path. It only depends upon initial as well as final position. So that's why internal energy here del u del u is dependent only on the initial and final, and it is independent of the path. So this is all about internal energy. Now this law, first law, that is we are talking about the first law. This law is applicable for all process in a nature, and the concept of internal energy is given by this law only. Where this concept came? By this first law of thermodynamics states about the concept of internal energy. It states that it is impossible to get work from any machine without giving an equivalent amount of energy. Let us see here. We have given a formula delta Q is equal to delta U plus delta W. Now we want work, but we don't supply energy. So if delta Q will be 0, so what will happen? Delta W is equal to minus delta U. It means that there is a need of an internal energy as well as to do the work. So it is not possible that both the things are 0 but work will be done. So it is not possible that delta U, no internal energy will be changed, no heat will be supplied, and in spite of this we are getting work done. So it is impossible. It is impossible. Okay, so the states that is impossible to get a work from any of the machine without giving it an equivalent amount of energy. Okay, so I hope you have understood this topic very clearly. So in next video I will come with the more details and more fun things. So I hope it is enough for today. Thank you for watching my video.